What we're gonna do right here is go back, way back into time.
Okay, so let's take a look at how the ESR is built. We will start with the 3D model first, and then we will move to the real video. So first thing you will notice on the real ESR is you can move these covers out, which we can do like that, like this. And then you will see there are a bunch of magnets, and they are 10 by 3. And in here there is some extra 1.5mm acrylic glued on top of the button, which is pushing this button, and that's basically it. We can hide this for now, and it will expose this side of the shoe, which will show us the NFC chip in here. Again, bunch of magnets, which are 1mm by 10mm. And in here we can see the mechanism of card lock, which contains this gear connected to the motor, which moves this lever left and right. On the beginning it just starts going to left until this infrared sensor will detect it, and then it will stop. That's our 0 position, and then it will start moving to the right, which will move this end up or then down, which will prevent cards from being drawn. Now, the button itself is just the button which operates the card lock. It's connected to the Jetson inside, and in here we can see these clips. The clips are there because inside them there are photosensors, which helps us recognize if the card is on the glass or not. And basically it's just one 3D printed piece with another 3D printed cover, and I will show you in a real video how it's done. But basically 2 photosensors are installed in here. The connection goes through here to the connector on the bottom, and well, this is basically the connector which goes inside. Let's do it this way. So it goes in here, and that way this connector connects to these pins in here. Now these pins are soldered to the PCB, which is secured with these 2 M3 screws, which is really important for them to be from nylon, not metal. Everywhere else we have metal screws, but in here we need to use nylon or some kind of non-conductive material, and it's because of here's the plus 5 volts, and it can be shorted against the metal body. Now let's put it all back, and we can see in here also this additional piece, which is the baccarat ramp, or yeah, I think we call it baccarat ramp, which is magnetic, so it can snap to it, and if you don't do baccarat but you do something else, you can just move it out, store it somewhere, and basically the shoe works without it. It's just for sliding the cards smoothly out if you want to go all the way to the table. Then we can, here's the infrared sensor, I mentioned that, and I think we can now hide this cover as well. We can do it on both sides, so let's hide it as well, and this cover as well. Yeah, we need to hide, of course, the magnets as well, and we are getting to the main structure. This is just the plastic piece to cover the hole, so we can hide it as well. And now we are getting Obviously we need to take off the top cover, which we will do easily, and the faceplate as well, which is made from the same 5mm acrylic. And this way we see the actual core of the shoe. We can take off the card lock, so let's hide that, and from this side as well. And yeah, we can take the clips out as well, but whatever. Just hide them. And yeah, this is how does it normally look like when you take off all the plastic. Yeah, so I think that's pretty correct, except we don't see the NFC because that's glued on the plastic as well. So what you normally see when you take off the plastic covers is this. So this, and something inside as well. So this is metal and it's built in one piece. Also the top covers as well. And also these two pieces, this piece and this piece. So basically all of this is one group. Maybe we can make it as a group. So this is one piece which look like this. So this is when you start to build the shoe. You get this piece made, and it's welded together. So this is the starting point. Now I'm going to put it back so we can go step by step. What you need to do if you want to get inside is you need to I'm going to show you in the real video as well, but basically you need to run some code to unlock the bottom. You take off the screws from here, 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 and all the side screws. And basically when you do that, it will allow you to open the shoe like this. If you can see here, basically there are two solenoids which are locking the bottom. So the solenoids, this solenoid and this solenoid, they are both screwed on this cover. And if you take a look from this side, basically if you select them, including the spacer, so this is how the piece look like. Yeah, let's see from here. So basically this is the bottom cover. There are two solenoids on it, screwed in, and they hangs on this part where you cannot really remove the bottom part unless you open the solenoids electronically. So that's kind of like anti-hacking device there, just hanging in here. So when you try to pull it down, it just doesn't work. So for now, let's just take it out. I'm going to select this. I'm going to open it like that. Yeah, I'm going to keep it here. I'm going to hide it actually a little better. Yeah, so this is what we have if you look inside the shoe. So there is a bunch of components. The main one obviously is the Jetson and the heatsink air vent or whatever. And you can see this is just the air vent, which is connected to the fan with 1, 2, 3, 4 screws in here. And this is just a 3D printed piece, and the Jetson just slides into it. That is then put back in here, so the bottom lies more or less flat to this metal piece, and these 4 screws in here, 1, 2, 3, 4, and 4, 5, 6, 7, 8, wait, 4, 8, they go in these holes. So if you put it back, you can see the air vent is connected with these 8 screws to the metal. That way we make sure the intake and outtake of the hot air is fine. Let's hide this again. And that's for the Jetson. Then the Jetson, we cannot unfortunately use the Ethernet connector from the side because there is this metal, so we cannot use it. So what we need to do is in here, as you will see on the normal video, we put the USB to Ethernet adapter, which is soldered directly to these pins in here. I will show that again on the video, and this is like the hardest part of building the shoe because you need to connect all of these pins to the USB 3 cable, which can be quite time consuming, annoying, and a bit dangerous because if you have really high chance to short something, but it can be done. So also we need to solder 4 USB cables here for the camera, but we will talk about it later. And we have the NVMe drive here with a heatsink, and then we solder the rest of the stuff to the GPIO, which I will show you the diagram of how it's done as well. If you're talking about this side, we have these 5.5 by 2.5 millimeter DC input connector, which is important to be 2.5, not 2.1 millimeter. So it's 5.5 by 2.5 millimeter. Otherwise, it wouldn't fit. Then we have this Ethernet connector, which we will create a short cable between here and the input of the connector, which you will see on the real video. And this is basically just the cover for the old USB-A, which we are not using anymore. So just 2 screws in, plastic cover, it's 3D printed basically, so there is just no hole like this. 8 screws here, and that's everything from this side. We can now talk maybe about this piece. So this piece here is the cover, which again is screwed on with 1, 2, 3, 4 screws. So if we hide it, you can see there is another solenoid which is screwed again with 4 screws as well. And the cable goes from here, again it's connected to the Jetson this way, through the transistor, the IP120 I believe. So this is the top cover lock, and something we didn't talk about is the actual glass, which goes from here where the solenoid cover starts all the way to the front, where it is held on this part, and it's removable. So the glass we can probably hide for now as well, and we can talk about the rest of the stuff inside. So we have the connectors, we have the Jetson with the air vent. Now we can take a look at this piece, which is quite important because that's how you get the power. So from the DC connector you are having 12 volts, which are going to the input of this DC converter down to 5 volts, if I'm correct, yeah, down to 5 volts, which operates the rest of the electronics. So in here also, these are the infrared sensors for the lever, but as you can see, you need to screw it from inside out. So basically you put one M3 screw in here, one M3 screw in here, the same for the another side, and this is connecting to the 5 volts as well, and to the GPIO connector in here. Then we have the motors. So this is motor 1, this is motor 2. So the motors are basically just the NEME 17 stepper motor, which is the pancake style, so they are just smaller than the normal ones. And let's for now, yeah, basically these motors, they require a motor driver, which is this part here and this part here. If I'm going to take this whole thing up, so, well, I'm going to do it so you can see how does it look like. So these are the motor drivers with the heat sinks on. So TMC2208, it's a quiet stepper motor, so it's quiet as possible. And basically all of these wires from the motor are going to be soldered on these pins. And yeah, the drivers are basically just like pushed in to these holes, and that's about it. Then motors are soldered 1 to 1. I will put a diagram, but then there is the 5 volt and 12 volts power, and it's connecting with 3 cables to the Jetson GPIO as well. Under it we have the relay, which we use for the LED lights in front. We will talk about in a few seconds, and also the second relay is for the solenoids. So LEDs and solenoids are currently controlled with the relay, which again is connected to the GPIO of the Jetson. So I'm going to put this back in. It's connected in one screw in here and one screw in here, which also holds the camera. So now it's time to talk about the front, where you have 1, 2, 3. Well, and no, I think we are using just 2 at the moment. So you have 2 LEDs, left and right, which are connected to 12 volts through the relay and controlled with the GPIO in the Jetson. They are 10 volts COB LEDs, 6,500 kelvins. So it's cool white light, and basically what you need to do is, yeah, you can put the 2 screws in here and 2 screws in here to hold it against this metal plate, and also you put some thermal paste in between the metal plate and the LEDs, so it wouldn't overheat. Then we have the camera itself. The camera itself is 260 frames per second. It's connecting by USB 2.0, so just 4 cables from the top all the way back down in here, where you need to solder them directly to the board. And there are also these 2mm standoffs, so the camera board wouldn't touch the actual metal, so otherwise it will short, so it's quite important. Now on top of that we have this adjustable lens, which when you turn everything on, you need to calibrate the zoom. So the zoom will see the mirror here. So basically this is the mirror which reflects the camera, so you need to make sure you see everything from left to right, and also the focus, so it's not blurry. We then have here this black part, which is basically just a felt. We have that also on the, I will show you later, but we have that also on the bottom part and on the sides, which I don't have in this 3D animation, the 3D model, because I was unable to do the bend here, but basically you will see later the cutout for it. So you just put another piece here, but you cover these things as well, so it wouldn't reflect. Otherwise these things can reflect on the mirror as well. So everything around the camera, basically there is a black photo drop, the black felt, to prevent reflection. Now if we talk about this part in here, this is the mirror holder. So yeah, you have the mirror, which is 1mm. Let's take a look from the side. So this is 1mm mirror, which if we move it away, you can see under it there are some holes for some magnets, and that's how we attach the baccarat ramp to it. So that's how does that work. So this is again just 3D printed piece of plastic with holes for the magnets, which are glued in, and also the mirror is glued in like that, and it's secured with the well, actually I can fix this. Yeah, it is something like this, and you put some small screws in, which helps to keep it into place. So basically just put some screw in here, like 8 or 10 millimeters long, and it will hold this piece, it will hold this piece in place. So yeah, here's the glass, which is on top of that, and that's it. Now we talked about all the main components. We have everything from the relays through the motor. Oh, this piece here, I forgot to mention, is ADS1115, which is analog to digital converter, because when we have the photosensors here, the clips with the photosensors, the cables are going all the way inside, and they are connected to a AD0 to 4, so basically 4 pins are connected for 4 sensors, and then the I2C cables are connected to a I2C of the Jetson, which you will see on the real video and also on the diagram. And that's about it for the 3D model. What I want to talk about as well is, let's do put it all together back. We can see in here is the black piece as well. So that's this is basically the most important, to hide the reflection of the glass and the metal part and everything, so the camera can see nice and clear image of the card. Otherwise you will have a lot of reflection from the metal, and then the camera can have a problem to recognize that. So I'm going to put this back, and although it looks kind of complicated, in principle, as you can see on the diagram, it's relatively simple, but it's kind of crazy to do it by hand. That's why we now are designing the new board, which should have all these electronics in one PCB, and I do have already in here the model of it, which will contain the battery itself as well, and the Jetson module from the bottom with the NVMe drive and stuff, with all the motor drivers and everything. But that's not for this version anyway, so I'm not going to talk much about it. These are just some test stuff for the PVM and the current regulator, but again, this not really important right now. What is important is I have these levers with this design, which is not as great because it kind of like can expand and shorten unnecessary. So I will probably return back to the original design, which was like this, and it bends like that. This seems to be working much better, and these are the fabrics cutouts for the sides. This is for the projector mount, so that doesn't really is about ESR. This is for the projector in the studio on the pole, so it's here just because, I don't know, why not. Plus in here you have another gear which goes in here. This is the original, so if you 3D print it, this is fine, but for example, if you create it out of the metal, which I have tried, 3D printed metal, you need to make this inside offset 0.50 millimeters larger, so the metal will fit to the shaft. Then also I have this piece, which is the faceplate, but this one is a little bit different. So this is my attempt to stop double card pulls with the traditional cards, which works really well for me, but more testing is needed, so I'm not sure if this is the final design or not, but that's about it. These are the clips with the photo sensors, but also with the brush, which is going to be cut 2.5 centimeters away from this line, so 2.5 centimeters somewhere here, and this is supposed to prevent fraud because it covers the reflection, which is 3D printed as well, but I don't like it as much. I actually hate it because it's not good, but that's how we do it for now, at least. Then let's take a look in here. We are using the POE injector and the splitter. So currently we have POE splitter in before the shoe. So the Ethernet connection goes here and the power goes from the splitter. But you can also use just the adapter and the normal internet connection. Up to you, depends on the situation. That's about this. That's about it for this 3D file. I'm going to show you now the actual video. How does it look in reality, which is not as clean as this one because there is a lot of cables going on. But let's take a look into that. Okay, so let's take a look at this video where we are going to connect the ESR to the Ethernet and to the power, so we can SSH to it, and therefore we can unlock the top and bottom cars. So I'm going to skip this for a bit until I connect, and here in a minute, yeah, try open it through the app or through the computer. SSH, here we go, this is the top cover unlocked. Now we can remove the cards, so we can remove the glass as well and the roller, which as you can see here, we are going to remove all of the parts. Okay, so here we go. Yeah, removing the clips, removing the glass, which is broken on my shoe, but that's just easy fix, so you can just laser cut another one. Now we need to open the bottom cover to get inside, which is currently accessible only by connecting the SSH and running the script called unlock bottom cover. Which opens the bottom cover for 10 seconds, and we can do it by just once the code is running for 10 seconds, you can just pop it open, and you can see now how does it look inside the shoe. So in here, first thing, you can see the solenoids, which are basically preventing anyone else without the access to accessing the ESR. I'm going to unplug it now, and we will plug it back in later. Now, if you take a look, yeah, we can actually unplug it for now because we are not going to need the power as it's already open. And let's take a look what we have here. So for now, we can remove the lever for the card lock and also the 3D printed gear, which may be changed to metal later, but we'll see about that. Let's remove it from here as well, and from this side as well, as we want to get rid of the covers, so we can go step by step to see everything we need. Maybe I can move this forward, so yeah, there we go. So this is basically the hexagon or whatever tool, 1.5 millimeter. You can just go through the screws one by one, and that way you can remove the side cover. And there we go. Now I just remove the side cover and the faceplate, and it will expose the metal. Now you can see I have these small plastic standoffs, I would say. That's because the metal is somehow a little bit shorter, but this is an issue which is going to be solved as soon as the next version is up. So just want to show you there are some spacers which are quite important, because otherwise the cards will not smoothly go out. Now let's take the another side as well. Again, we can just remove all the screws, the black ones, and yeah, there is the NFC, the white circle, and yeah, once the cover is removed, we can also see the metal with a bunch of cables for the photo sensors and the button. If I am going to move even further, yeah, I'm going to show you, as you remove the side covers, you should be able to remove this front part with the magnets and the mirror as well, which is just a 3D printed piece. And what I'm doing here is I just try to show you where the magnets are, and you can actually really see them here. So all good. We are going to take a look at the top solenoid, which we can remove the cover with 4 screws. Yes, these are the old screws. 4 inside is for the solenoid, and 2 and 2 on the sides is for the cover. So I'm going to remove that. Yeah, so here we can see, once again I'm going to put it back. So the screws on the sides are for the cover, so it's enough to remove them if you want to get in. As you can see, there's a transistor with a resistor. I believe the resistor is 1K and or 10K, I'm not sure, I will check. But yeah, I mean, we don't need to remove the solenoid, so we can actually, yeah, as you can see, the power goes straight to the solenoid, and we are shorting the ground in order to move the sensor, the solenoid, and the yellow cable is for controlling from the GPIO. So we can move from this to something else. Let's put it back together, and here we can talk about the LEDs and the camera. So here are the 4 screws for the camera, and there are the spacers I mentioned on the 3D side, and that screw also holds the big 3D printed holder, the plastic holder for the motors. Now about the LEDs, they are basically just connected to the 12 volts through the relay and screwed in, and as I mentioned before, it's quite important to have the thermal paste there. Now I'm talking about the felt, which helps us to get rid of the reflection, and now this is the focus and the zoom and the focus. Adjust for the camera, and these transistors, actually we don't even need them because this was used before I started to these 2 transistors basically we don't even need. They are not connected to anything. I just left them there for a case, but they were used before for controlling the LEDs, but it overheats too much, so I switched to relay. Now let's take a look what we have here next. Yeah, so I'm going to remove these two screws, not fully, just enough so I can take this big plastic off, which is the carrier for the motor drivers and the AC or the analog to digital board. Yeah, as that is removed, we can see on the so I'm going to show you again. So in here we remove it, and on the bottom you can see the relay board, which has the small 3D printed board, 3D printed bottom as well, so it wouldn't touch directly the metal, which I have in most of these modules. And yes, basically on the left side there is input of the power and input from the GPIO, and to the right side is basically just lights. Now in here you can see these are the TMC or TCM2208 motor drivers connected to the motors and to the power, and you can also set up the current limits there, which I am going to describe later probably. So that's about it in here, so we can move from here somewhere else. I'm going to put it back together. We can skip that part. Yeah, I'm showing it again, fine. Yeah, the cables are kind of in the way, so actually for now I'm just removing the sensors, the transistors, because we don't really need them anyway. So yeah, it's much cleaner like this. Okay, let's go next. What we have here is this analog to digital board and the motor sensor. So the analog to digital board is currently not screwed in because I was trying multiple different ones, but basically there are two holes in order to screw it in, so you can do that. But for me, as I'm tinkering with it, it's good enough like this. So yeah, there you go, just 5 volts plus minus, I to C from the Jetson, and four cables from the clips and the photosensors with again with the resistor, which is again I think 1K or 10K, I'm not sure, I will take a look. It's going to be in the diagram. So yeah, and they are, so in here they are, well, can I move this? Yeah, so here they are connected straight, and then the resistor is going, they are all together connected here, and the blue is ground. Okay, so now we can see in here there is the DC to DC converter, step down from 12 volts to 5 volts, and again there is the 3D printed bottom, so it wouldn't touch directly the metal. But also in here you can see this red board, that's PWM for the LEDs, which is not currently installed on any other ESR than mine, because this is just a testing in order to prevent the overdraft of the current, and it also overheating, which helps but not enough, because also the DC to DC converter is producing quite a lot of heat. So there is another way I need to fix this issue, but basically this is just the PWM board which is glued on that part, which I didn't done permanently because I'm not sure if I'm keeping that yet, but we'll see. Now that's the connector for the solenoids. We talked about that. Now I believe we can skip a little And yeah, there we go. So I'm going to rotate the shoe, and here I'm going to talk about the USB soldering. So this in here, the red, white, green, and blue, black cable, that's for the camera. So this USB 2, just 4 cables, that's relatively straightforward to solder. It's not that big of a problem, but this one in here, the Ethernet to USB, is a bit more painful because there is a lot of cables, because it's USB 3, and it needs to be soldered really carefully. And then I put the UV glue on top of that so it wouldn't move. When you're soldering this, or basically anything you're soldering here, be careful, because we don't want to short this port, as it's like $1,000 or something. So as I said, we cannot unfortunately use this pre-installed Ethernet port. We need to use this the Ethernet to USB converter, at least for this version. Obviously that's solved with the new version with the custom PCB. And I have crimped my own short teeny tiny cable so it can move from this Ethernet to the Ethernet converter. Okay, let's take a look what's next. Yeah, if you use banded tweezers, you can get under that Ethernet connection, and you can actually unplug it that way, because you need to push that small lever there, and that's how you can expose the rest of the GPIO if you need to change something. It's quite tight, and it's a little bit of nightmare to solder everything on the pins, but I have done it, so in theory it's possible. It's just not sustainable for scaling, of course. That's why we are going to have the custom PCB board. Yeah, so here again, this is the main power, 12 volts, so plus minus, and as I said, it's 5.5 by 2.5 millimeters connector, because there are two types, 5.5 by 2.5 and 5.5 by 2.1, so big difference. Now this is the Ethernet R345, and then just the blind cover for the old USB-A. Now what we have here again, the infrared sensors. So they are there, just 3 cables, plus minus, and input from the GPIO, but these 2 screws are kind of hard to install, so you need to use the 90-degree bent Allen key to do it, but again it's doable. So it's threaded on these holes are threaded, and yeah, basically I'm showing how the sensor works now. As soon as it hits the sensor, it will stop moving the motor, so it will go like that only, not all the way. And the button, so there's the side button, through the resistor to the GPIO. And now I'm talking about the importance of having the nylon screws, because as you see, they are touching these. Basically the screw is touching these 3 pins, and this screw is touching 3 pins. But if you have metal pins, it will short them to the ground, because the metal is ground. So use nylon screws in here. Everywhere else you can use the metal screws, just in here use nylon screws. And this is the plus 5 volts, this is photosensor 1, photosensor 2, and this is the button, basically, so it recognizes if the clip is installed or not. Okay, now what we are going to do is, yeah, I can take it apart and show you. There is also the small 3D printed spacer as well. That way you can ensure the connectors are right in the middle of the clip, so it's a little bit of offset, which can be solved by getting a thicker PCB, which I didn't have at the time, so this is how I did it, but it's not a big deal. Yeah, here they are, the nylon screws. So that's that. I'm putting it back together, and what else we have here? Oh, so here I'm talking about the felt. So this is just glued on, and this decides why I don't have on the 3D renders is because they go all the way on top of these as well. So it's kind of hard to make it in 3D. But basically, we are just covering the top, bottom, left, right with the felt to prevent the reflection. Oh, so these are the clips. Okay, but I talk about them. Oh yeah, here I'm going to show you how does it look inside. So this is just the cover, and there we go, that's 3D printed. But now the interesting part is here. So in here you have two photosensors, as I mentioned, but they are going one like here, another like there, 1, 2 again. So basically these middle two are 5 volts, and this is photosensor 2, this is photosensor 1. So, and then also this pin, and also the pin is connected to the 5 volts as well. That's how it can be detected when plugged in. So they can also be shorted, it doesn't matter, because both center ones are plus 5 volts. And you can see the arrow, basically, yeah, where the arrow points there is no cable, but where the arrow starts, that's where you put the cable. So if I open it, this one, it will be mirrored, and if I do that again, you can see I'm showing in here, so it's mirrored. But what I'm talking about, where the arrow starts, you can see there on that side there is the cable, the first pin connected to 5 volts. Okay, let's skip forward. So yeah, these are basically the yeah, I don't remember the name, I will put it somewhere here on the screen. That's the connectors or whatever, and they can be short like this or they can be long like that. It doesn't really matter, because the legs are long enough to get soldered on it anyway, so that's okay. These are the photosensors, and they go in like that, so I can, yeah, and basically you just connect them like that. You just solder that, and there you go. Here's the faceplate. Yeah, obviously you see there is like kind of too many holes in here, and that's because the solenoids were originally in here, but as we get the jets and boards and everything, it needs to be moved more to the left, so it drills some holes and move it all the way to the left, so these holes are not going to be needed anymore. Yeah, but that's about it. So solenoids, they are latching on there. We explained it on the 3D model, so they should be good to go. And also there is these small spacers, so the distance between the end of this and the metal will be enough to latch on the metal part there. Otherwise it may be too short and it wouldn't really close. Also you can use some thread locker or maybe even weld it to make sure no one can just unscrew them, or also you can just drill out the heads. You can just drill out the heads, so it will be virtually impossible to get them out. So there are like 3 ways how you can do that, but basically no one should be able to just remove them by unscrewing. Now, yeah, it's kind of important to give them some free space, because as you have a lot of cables, you need to make sure in here in this area and also on the other side there is enough space. You see, the cables go kind of like this way, not straight like that, but they go in this way. So in here there is enough space for the solenoids to move. Okay, so I'm going to put it back together now. Screw it in, screw it on. Make sure the cables are not, they're like inside the gap, not under the acrylic. So that's what I'm doing here with the tweezers. And yeah, I'm just screwing it back on. Again, make sure the cables are inside the gap, not under the acrylic, otherwise it will not fit. The cables in here as well. And you just screw it in. Screw this one as well. These are the smaller screws. I think it's M2 or something. I will take a look into that. I will put it on the screen. But these two are smaller, but they need to be long enough to go to the plastic piece. And put the clips back on. Yeah, there we go. That's how we can have connection. Then tighten up the nylon screws. And the same on the second side. Basically, yeah, you can also put some tapes in here so the cables are not going to get out of the holes, because then it's a problem if you want to put the magnetic cover on top of it and the cables are in the way. So that's why I'm going to do the same in here. Make sure the cables are nice inside the holes. Screw it on. Don't forget to put the faceplate, of course, in between them while you do that. And yeah, make sure. Yeah, this is another way how we can make sure all the cables are there. So first screw it in and then put the cables inside. There we go. Screw everything back together. Now let's put back the gear for the card lock and the lever. Yeah, they are. Yeah, the orientation matters on this end, so it should be flat in here, but it should go inside the shoe to stop that, so it can properly prevent the cards from getting out. Otherwise, you wouldn't be able to close it anyway. Make sure the cables are kind of nice and tidy, although they are a mess. But that's about it. Yeah, 100% good idea to do before you close the shoe is, first of all, make sure you connect the solenoids, because if you just close it without connection, you will be never able to get back. So make sure they are connected, as I'm doing it here. That's the first step, but also test them, because something could go wrong, and if they are not working properly, it would be a nightmare to get inside the shoe. So I'm going to run the code now to test if the solenoids are working properly. So I'm testing the code. The solenoids will get pulled in both at the same time. So now you see, now they are pulled in, so we know that it works. And in here I'm going to show it one more time from different angle. This is how they are open or closed actually. And now when I run the code, there we go. Now they are open. Okay, so now if everything works fine, I try to tuck the cable in, which again it's a mess, but let's say for now that's all we have. I'm going to put the metal plate back. Also on the end I can put the screws in, so it will hold even better. But as you can see, I have a problem because the cable gets in the way. so it doesn't work properly. I cannot close it properly, so that's why I'm going to open it again, make sure the cables are out of the way, and now I'm going to close it again where everything seems to be nice. Yeah, now I would put the screws potentially in these holes, but I'm not going to do it for now because I need to have quick access as I'm still developing it, but that's what I would do in the final. Now we can put the clips back, just put the covers there as well so it's not so ugly, and we can put them back. Same on the second one, make sure the glass is correct, so put back the glass, yeah, and well, ideally in one piece of course, but that's what I have unfortunately now. Okay, let's keep this forward, and I believe that's basically it. Put the cards back in and you are ready to go. Top cover as well, and that's about it. So as you can see, there's that, and hopefully this will help you to maintain or create or whatever new shoes in case I'm unavailable, let's say. And yeah, that's about it, so have fun.